Hi guys, today in class we're going to be learning about eclipses and tides. Everybody go ahead, take a minute, pull out your composition notebooks, go ahead and put today's date in, 3-2, and these are going to be class notes continued from 7.3. So they'll just continue on from our notes from class on Wednesday. When you guys are all done, we'll move on to the next slide, but go ahead and we'll be writing everything that's written in white so you can start at the top with capital letter B, eclipse. Go ahead and unpause me when you guys are ready to move on. Okay, let's go ahead and talk about what an eclipse is. The word eclipse literally means to cover up. So eclipses happen when the sun and moon occasionally line up so that we have either a lunar or a solar eclipse. You can see here down in the bottom left-hand side, this would be an image of a lunar eclipse, and you can see here over on the right-hand side, that would be an image of the solar eclipse, much like the one we had in August. We're going to start by talking about lunar eclipses. So number 1, underneath capital letter B, a lunar eclipse is when the moon passes into or is eclipsed by the shadow cast by Earth. Go ahead and pause me. When everybody's done writing, I'll continue. The image below shows you the anatomy of a lunar eclipse. Think back to the activity we did in last class when we had our sun set up in the center of the classroom represented by the light bulb. Our Earth was our head with our eyes being our perspective of the solar system. And then over here, we have our moon, which is represented by the munchkin. Now, when we had our sun, earth, and moon in that order, we started by holding the moon nice and high, and that showed us our full moon when we have this alignment right here. We then took the munchkin and kind of lowered it down until the shadow cast by our head, the earth, hid the moon. When the moon slips into that shadow, it's an eclipse. Depending how much of it slips into the shadow and which type of shadow it slips into, we get 3 different types of lunar eclipses. So let's start by learning about the first type of lunar eclipse. The first type of lunar eclipse is called penumbral lunar eclipse. And this is when the moon only passes through penumbra of Earth's shadow. The penumbra is the outer, lighter edge of a shadow. Go ahead and pause me while everybody has a chance to write this down. These images down below here almost don't look like the moon is eclipsing at all. You can just start to see along this outer edge here a slight shadow cover part of the moon. That's what a penumbral lunar eclipse looks like. It's not very exciting to see. In some cases, you might not even know that it's happening because the penumbra lets in a little bit of light that bends around it. Let's move on to our next type of eclipse. The partial lunar eclipse is when part of the moon passes through the umbra of Earth's shadow. Number 1, the umbra is the darkest inner part of the shadow where no light can reach. Go ahead and pause me while you have a chance to write this down. You can see right here an image of a partial lunar eclipse, much like the one we had on January 31st of this year, where the moon is passing just slightly into that shadow and only part of the moon is getting covered up when it reaches totality here. There's still a little sliver. There's my waxing crescent right there. Still a little sliver of moon that is still visible. Okay, let's move on to my final type of eclipse, and that's my total lunar eclipse. A total lunar eclipse is when the entire moon passes through the umbra of Earth's shadow. We've had a few total lunar eclipses in the last few years, and we have one coming up next year. Go ahead and pause me while you have a chance to write this down. An interesting thing happens as the moon reaches totality. You can see here the moon slowly slipping into the umbra, and then the moon slowly slipping out of the umbra. At totality, however, the moon is visible. It becomes visible because all of those different light waves, most of them are filtered out except for the red, which bends around and is reflected off of the moon, making it look red just as it reaches totality. Now, our next total lunar eclipse that we have to look forward to is just under a year from now on January 30th, the evening of January 30th, and it should be a beautiful eclipse visible from Florida. Let's move on to solar eclipses. They're when the sun is covered or eclipsed eclipsed by the moon. Go ahead and pause me. This image below shows us the geometry of a solar eclipse. If you think back to the lesson we had at the beginning of the year on the day of our All-American eclipse, some of this might make sense to you. So our sun hits our moon, which is much smaller than the sun, and behind the moon, a shadow is cast. Much when you guys are walking outside on a sunny day, you look at the ground, depending on the angle of the sun, a shadow is going to be cast on the ground. That shadow then falls somewhere on Earth. You have to be standing at that specific location, in this case where you see my cursor, in order to see the sun eclipsed by the moon. Because the moon is so small and the sun is so big, the moon is not big enough to cast a shadow over the entire Earth. That's why it's pretty tricky in order to see a total solar eclipse. If you remember back to when we demonstrated this at the beginning of the year, we drew a big Earth on the pavement. We went outside, we held up little models of the moon in between the sun and the Earth as our pavement, and you guys saw little shadows of the moon cast upon the Earth. That shadow, as the moon, Earth, and sun move, well, the sun doesn't move, but the Earth and the moon move, a path is created, and that's known as the path of totality. Let's start with my total solar eclipse. A total solar eclipse is when observers in the umbra shadow see a total eclipse on the path of totality, which is about 10,000 miles long, only 100 miles wide. The path of totality is the shadow path that the moon casts on the Earth. Go ahead and pause me, and when you're all ready, we'll continue. The path of totality for our All-American eclipse stretched from the coast of Oregon all the way across America, thus the term All-American eclipse, exiting in South Carolina. In order for us to have been able to see it, we would have had to travel up to South Carolina or North Carolina in order to stand on the path of totality. Here in Florida, I think we were about at 80%. So when we saw the moon pass in front of the sun, it didn't cover up the whole sun. We got what's called partial solar eclipse. I'll show you a quick image of a total solar eclipse right there. And now let's move on to a partial solar eclipse. This is when observers are in the penumbra shadow. So we're not quite on the path of totality, but we still fall off to one side of it. And here's my last image of partial solar eclipse. Go ahead and pause me if you need a little more time. Our last type of solar eclipse is known as an annular eclipse. This is when the moon is at apogee and does not completely cover up the sun. In the last class, we learned that the moon's orbit around the sun is elliptical. That means that sometimes it's closer to the Earth than others. You can remember back to the PowerPoint where I showed you the two images of the full moon. One was at apogee, one was at perigee. When it's at perigee, it's closer to the Earth by about 50,000 kilometers, and it looks much bigger. At perigee, the moon can cover up the entire sun, and the shadow cast will reach the surface of the Earth. When the moon is at apogee during an annular solar eclipse, the shadow does not reach Earth. Therefore, we see a ring around the sun, thus the term annular eclipse. Go ahead and pause me if you need a little more time writing this down. We have an annular eclipse coming up in just a few years here. In about 5 years, on October 14th, there will be an annular eclipse that will be viewable from here in Florida. But we have to wait one more year to see another total eclipse in North America. Path of totality will stretch from Texas to Maine. You'll have to travel a little bit north if you want to stand on that path of totality, but a partial eclipse will be visible here from Florida. Okay, let's move on to our last section of this unit in astronomy. We're going to talk a little bit about tides. Anybody that's interested in the ocean, anybody that has gone out boating, gone over the San Carlos Pass, either to Fort Myers Beach or to Sanibel or Captiva, has probably noticed that sometimes the water recedes and sometimes the water is a little higher than others. This is due to tides. The tides are created when gravity from the moon and sun make the oceans move. When they pull together, we get stronger tides. So because water is fluid, the gravity is able to tug on the water, and the water moves towards that force, towards that gravitational pull. The image below, I have two pictures, one of what we call our spring tides, one we call our neap tides. You'll notice that the alignment of the sun, moon, and earth is pretty important for both tides. During spring tides, they're all in alignment in one line, either as our new moon or as our full moon. During our neap tides, the sun, earth, and moon are perpendicular to each other. Let me go on and explain these two types of tides. A spring tide occurs during the full moon and the new moon when the earth, sun, and moon align, and this gives us our biggest tidal range. Go ahead and pause me so you can get this written down. If you look at this following image, you'll understand how these big tides are created. The solar tide is much smaller than the lunar tide, but it does tug on the fluidity of the earth. The lunar tide is much bigger, and when these two tug together, the resultant tide is quite large. Because the earth is round and it spins, depending on whether it's new or full, we always get an opposite bulge of water on the other side of the earth. So we'll have a high tide here and a high tide on this side as well. Depending where you are on earth as the earth spins, you'll cycle through the highs and lows probably twice a day. Our neap tide occurs during the quarter moons when the earth, sun, and moon are perpendicular to each other. Because the sun and moon are both tugging in different directions, one is tugging 90 degrees to the other one, the tidal range is much smaller as they tend to cancel each other out. Go ahead and pause me before you write this. In this image here, you can see how the solar tide is tugging from right to left, and the lunar tide is tugging up and down. The result of that cancels each other out a little bit, and the resultant tide isn't nearly as big as during our spring tides. Some cool places in the world where you can really see these tidal differences are in the Bay of Fundy and Severn Bay in the UK. The Bay of Fundy is up in Nova Scotia. Here's a picture on the left-hand side where you can see boats in water on the bottom, and then where the water has completely receded, leaning against those same piers during the tide. The flow has gone all the way out of the bay. Again, picture on the right, you can see there's more water, and as the water has receded, leaving behind bare rock on the right. There's a lot of interesting engineering difficulties people in these areas have to deal with, but overall, the water, as it proceeds back and forth, can create some pretty cool geological formations. On this bottom right-hand picture right here in the Bay of Fundy, you can see that as the water recedes, because of the force of the water, it's eroded and weathered this rock into some pretty neat shapes. Sometimes people can walk out there, but sometimes there's so much water that they can't. In the Bay of Fundy, the largest tidal difference in the world, about 50 feet. I mean, sometimes there's 50 feet of water, and then during a low tide, there could be any water in that same area. The last couple slides here show you some cool stuff that can result from tides. In some areas where you have a small inlet to a larger bay, as the tide comes in and recedes, it creates what's called a tidal bore, which is in effect a standing wave. Surfers around the world put this on their bucket list because sometimes that standing wave can last for 1 to 3 miles, depending on the location. And if you miss that first wave, you can always jump right back on and catch the second wave. Last but not least, here on the coast of Florida, you'll see similar things to these pictures of the Bahamas right here. When you have barrier islands, such as we do, like Fort Myers Beach, Sanibel, Captiva, North Captiva, and Cayo Costa, you get pretty interesting tidal patterns through the inlets. Usually the inlets, due to the velocity of the water as it rushes through during those high highs and low lows, creates very, very deep water, which would be uncharacteristic for this area. In Current Cut Inlet in the Bahamas and Eleuthera, you get depths that reach up 90 feet. Surrounding water, probably about 7 to 10 feet in terms of its max depth. They also create for some very interesting geology and in some cases, very complicated navigation. Right now, you guys have the rest of class to prepare for your astronomy test on Tuesday. If you go onto Cougar Campus and you look into the astronomy topics folder, you'll see downloaded in the downloads a document titled Astronomy Review Jeopardy! Go ahead and use your device to click on that and feel free to play the game either individually or in groups. If you have any questions on anything you learned today, send it to me on Monday so that you're all ready for on Tuesday.